Hey guys, today we're going to multiply and divide. So to get started, here's a do now. So press pause and try it out. And then when you're ready, press play again. So when multiplying radical 5 times radical 5, you should be getting radical 25. 5 times 5 gives us the 25. And that should simplify to just 5. So notice that when multiplying identical radicals together, the inside came out of the radical because their product was a perfect square. So that's a little shortcut that you're going to be able to use for some of the problems that you're going to do right now. So we're starting with multiplying. And when multiplying radicals, you want to make sure that you multiply the insides and the outsides. You never want to cross over the radical. If there's a number that is outside of the radical, it cannot multiply with a number that is inside the radical. Same thing with the variables. Something outside cannot multiply with something that is inside. So that's the only thing you want to be careful with. So why don't you press pause and try out number 1, and when you're ready, press play. So number 1 here, multiplying the outsides together, 3 times 4, you get 12. And then multiplying together the two insides, 2 times 8, you get 16. Notice the two numbers that were on the outside, their product stayed on the outside. And the two numbers that were on the inside, their product stayed on the inside. From here, you do have to make sure that you simplify, because here are our directions, and they do say simplify completely. So radical 16, we should know, comes out as a 4. We're going to make sure that we bring down the original 12 on the outside to multiply with this new 4 that came out, and 12 times 4 gets us 48. Now, you could have simplified the radical 8 that was originally there first if you wanted to. However, after you take the product, you would still have to simplify again. So here's where multiplying and dividing is different from adding and subtracting, because when you go to multiply and divide, I would hold off on the simplifying until the end if I were you. Otherwise, it really is just extra simplifying you're doing, because a lot of times after you multiply, you're still going to have to simplify anyway. Adding and subtracting was different yesterday because for those, you had to simplify first in order to get those like radicals. So definitely make sure that you're following that rule for adding and subtracting. Multiplying and dividing really could go either way, but I would hold off on the simplifying until the end. So why don't you press pause and try number 2, and when you're ready, press play. All right, so number 2, the outsides, we have 2 times 4, which gets us 8 on the outside. And then inside the radical, we have 3x times 6x is 18x squared. So from here, simplifying, we can break up this radical. 18 is 9 times 2, with 9 being the perfect square. X squared is a perfect square, so we don't have to break it up as anything. 9 comes out as 3. X squared comes out as x. And we're going to remember to bring down that 8 from the outside to multiply with the 3. So you should get a 24x on the outside, and inside is just that 2 that was left over. So your final answer is 24x radical 2. Now, number 3 is cubed roots. It is going to work the exact same way as square roots. So why don't you press pause, give it a shot, and when you're ready, press play. All right, so outside, 5 times 4, we get 20. Inside the cubed root, x times 8x to the 7th is 8x to the 8th. Remember, when multiplying variables, you add the exponents. So 1 plus 7 is 8. And from here, we simplify. Now, simplifying this cubed root, in terms of the number 8, 8 is a perfect cube. It comes out as 2. However, x to the 8th, when you are dealing with variables, you want your exponent to be a multiple of your index, which is 3 here. So that has to break up as x to the 6th and x squared. X to the 6th being the perfect cube because it's a multiple of 3. So dividing 6 by 3, we get x squared coming out. That other x squared is left inside. Don't forget to bring down the 20 to multiply with the 2 that already came out. So your final answer here should be 40x squared and then cubed root x squared. All right, why don't you try number 4, press pause, and when you're ready, press play. Okay, so number 4 here, A times B on the outside is AB. On the insides, you have AB to the 7th times A. So in that radical, the A times A is A squared. B to the 7th times B to the 1st is B to the 8th. And because our index is 2 and both of our exponents are multiples of 2, this radical is already ready to be simplified. Everything's a perfect square. A squared comes out as A. B to the 8th comes out as B to the 4th after you divide by your index 2. We're going to remember to bring down that AB that was in the front to multiply with these new pieces that just came out of the radical. So A times A is A squared, and B to the 1st times B to the 4th is B to the 5th, and that is your final answer. All right, we're going to do the same thing, number 5. Why don't you press pause, give it a shot, and when you're ready, press play. So as you can see, multiplying the outsides, 4 times 2, I got 8. Inside, 5 times 10, I got radical 50. Simplifying, 50 breaks up as 25 times 2. 25 is the perfect square. It comes out as 5. Bring down the original 8 that we got from multiplying, and 8 times 5 is 40, and then radical 2 is left inside. Okay, number 6 now. Notice we have a binomial times a binomial. Anytime you are multiplying together two binomials, make sure you are using either FOIL, double distributing, your lattice method or box method, whichever method you preferred when we did polynomials. You can do it again here with the radicals. So I'm going to double distribute or do FOIL. 2 times 6, we should get 12. 2 times negative radical 3. Well, first of all, we have a positive times a negative, so I know this is going to be negative. And then the 2 and radical 3, unfortunately, are on opposite sides of the radical, so they cannot actually multiply together to make new numbers. They are just going to merge together with the 2 staying on the outside and the 3 staying inside. Same thing here now when you do radical 3 times 6. They are on opposite sides of the radical. Positive times a positive, you should get positive 6 radical 3 there. Last one, we have a positive times a negative, so this product will be negative. And then radical 3 times radical 3. Now, here's where you could do the little trick from the do now if you wanted to, or you can make it the radical 9, and then just remember that radical 9 is just 3. So if you had recognized that trick from the do now, you could have gone straight to putting minus 3 right there. But if you didn't notice it, you could have done what I just did, where you did minus radical 9 and then reduce the radical 9 to 3. Now we have to combine like terms. Remember, this is going back to yesterday's lesson with adding and subtracting. They have to have the same radical in order to combine. So here the 12 and the negative 3 both do not have a radical, so they are like terms. 12 minus 3 giving us 9. And then we have our 2 radical 3's here. They can combine because they are the same radical. However, remember it is just the coefficients in front that are going to actually combine. -2 and +6 is +4, and the radical 3 stays the same here. So this is your final answer, 9 plus 4 radical 3. Why don't you try number 7? You can press pause, give it a shot, and when you're ready, press play. All right, so number 7, I already did the distributing here. 4 times 4, you get 16. 4 times radical 6, +4 radical 6. Negative radical 6 times 4 is -4 radical 6. And negative radical 6 times positive radical 6, again, if you needed to, you could actually multiply, get negative radical 36, which is just -6. So again, if you notice the shortcut from the last one and the do now, you could have just gone straight to -6 there. Combining like terms now, we have a 16 and a -6, so we should get +10. And then now notice right here in the middle, we have a +4 radical 6 and a -4 radical 6. So that really gives you a 0 radical 6, which cancels out to just 0. So you are left with just the 10 here. Why don't you give number 8 a shot, and when you're ready, press. All right, number 8, big thing to remember here is that when you have a binomial squared, you do have to write it twice and double distribute, just like we did for question 6 and 7. So if you didn't do that, if you forgot, I would star it for myself to remind me in the future that we do with squareds have to write them twice and double distribute the whole thing. Otherwise, in the middle there, you would have lost that 4 radical 5. So your final answer here should be 9 plus 4 radical 5. So that's all the multiplying with radicals. So hopefully you have no questions. We can go over it otherwise. So let's turn to the next page and let's do some dividing. Dividing is going to work the exact same way as simplifying. If I were you, I would, or the exact same way as multiplying rather, sorry. If I were you, I would hold off on the simplifying until the end, because you will have times where after dividing, nothing has to get simplified at all. So if you simplified first, you really just created some extra work for yourself, which is not wrong, but why make extra work that it's not necessary, that you don't have to do? But just like multiplying, outsides will get divided and then insides will get divided. We cannot cross over that radical. So here, number 9, the 80 and the 5 are both inside the radical. Their quotient after you divide will stay inside the radical. So here, 80 divided by 5, you should get radical 16. From there, now you can go ahead and simplify. Radical 16, we should know, is a perfect square, comes out as 4, and there is your final answer. So why don't you go ahead and press pause, give number 10 a shot. Remember, just like multiplying, you'll do the outsides first, then you'll do the insides, and then from there you can see if anything needs to simplify. When you're ready, press play and see how you did. All right, so number 10, like I said, we're going to divide the outsides first. 10 divided by 2, we get 5. Because they were both on the outside, their quotient stays on the outside. And now inside, we have 24 divided by 2 gets us 12. And from here, we can simplify. 12 breaks up as 4 times 3, with the 4 being the perfect square. It comes out as a 2. Don't lose the 5 that was on the outside after we divided. So you should get here 10 radical 3 as your final answer. All right, number 11 now. Cubed roots, just like square roots. You're going to divide the outsides, then the insides. Big thing to remember here with variables, though, is when you divide, you subtract the exponents. So why don't you press pause, give it a shot, and when you're ready, press play. Okay, number 11, I did the dividing already. Outside, 6 divided by 2 gave me 3. Inside, 256 divided by 4 gave me the 64 that you see there. And then x to the 14th divided by x squared. Again, keep the base, subtract the exponents. 4 minus 2, you get 12. Now, simplifying, remember, we're dealing with our cubed roots this time. 64 is a perfect cube. It comes out as 4. And x to the 12th is a perfect cube because 12 is a multiple of 3. So we divide it by 3 and we get x to the 4th. We're not going to lose the 3 that was on the outside there. 3 times 4, we get 12x to the 4th as our final answer. And we see that everything in the cubed root had simplified. So there are nothing left inside that cubed root for us. Okay, last one, bear with me. For this one, the entire numerator is being divided by this 3 radical 2. So both the 3 radical 10 and the 15 radical 2 have to get divided. So if you want, you can break them apart as their own separate quotients and do each one of these completely separately if you want. 3 divided by 3 is 1 for the first one, and then the 10 divided by 2 gets me radical 5, plus 15 divided by 3 is 5, and then radical 2 divided by radical 2 is radical 1, which is a perfect square. It comes out as 1, which when we multiply it with 5 does not actually do really much for us. You are just left with 1 radical 5 plus 5, or if you want to leave it as just radical